Hello everyone, welcome to the explanation. So in this video I'll be discussing about important question on recursive function. Okay, so many of my students, they have requested to prepare a video on recursive function or important question or old question on recursive function. Okay, so in this video I'll be totally discussing about the question that has been asked using recursive function or some important question, as well as I'll also try to clear the concept of recursive function. Fine, so please stay tuned with this video. So first question that can be asked in exam is what is recursive function? Okay, so I'll cover 2-3 questions from theory part and then I'll go to the program. So what is recursive function and what are the conditions? Okay, what are the two conditions that must be? What are the two conditions that must be satisfied for recursion? Okay, so first, what is recursive function? A recursive function is one that calls itself. Okay, a recursive function is a function that calls itself to solve a problem. Okay, so generally if you suppose there is a function called sum and inside this function it is again calling itself, so this is a recursive function. Next part is two base condition. So two base conditions can be, one is the function should call itself. Okay, should call itself, and second condition can be the problem statement should contain stopping condition. Okay, so there should be a stopping condition, a base condition we can say, where a program terminates. Okay, and next one more condition can be program should be written or defined. Okay, so program, let me write, program should be defined in term of previous result. Fine, so this is the first condition, a very basic question that can be asked for 4 marks. Let's go to another question that can be asked from this chapter, that is I think this question I have already uploaded, so I am not going to give you a solution. Please see my previous videos. That is, differentiate between recursion and iteration. Okay, so this question can be asked. Please see my previous video that I have uploaded. I have uploaded a separate video for this question, so please go through this question. Next question can be explain global, local and static variable. Okay, so local variable, it is defined inside a function. Global variable, it is defined outside a function, and the entire program can use this variable, we can say. And static variable, it is not destroyed on exit from a function. Okay, so the scope of this variable is not destroyed whenever we exit from a function. So again, please go through this all the variables, these 3 variables, and if you have any confusion, if you want to make a separate video on this topic, please let me know. I'll prepare a separate video for this. Okay, so these are the questions that can be asked from recursion in a theory part. Let's go to the programming very fast. Okay, so lots of question has been asked from me that to solve these questions, so I have come with all the solutions for all the questions. First question that can be asked in exam is, it's a very basic question. Okay, so write a program to read a number n from user and calculate the sum of first n natural number using recursion. Okay, so this question can be asked with a tag question. It means that a previous question will be there and then this question can be asked for 4 marks. Okay, so this is a very easy but very important question. So let me write the code for you. So let me erase this question so that I'll get space. Sum of n natural number. Okay, so for this what we'll do, has include your program is there. So we are going to declare a function. Okay, so int sum, let me declare my function name as sum and argument which is again of integer type. Now main function. Okay, so let me declare a variable n for number and sum for sum. Printf enter n. Okay, I think it's very easy till here. Scanf %d address of n. Now we want to call our function. Okay, sorry, so as I have declared my function here, I cannot declare my variable name as same, so I'll just declare it as s. Fine, so let me call my function. Let me call my function, that is sum, and I'll pass my variable or my this variable n here. Okay, so after calling this function, I don't know what is the result, so let me go to the called function now. Okay, so again function, this is called function declaration. Now let's go to the function definition part. Int sum int, let me write the value here as num. Okay, so now for using a recursive, let's see how it is used. So if num is less than equals to 1, it means that what the question is telling, write a program to read n number from user and calculate the sum of first n natural number. It means that if you are reading 1, 2, 3, 4, 5, you have to find the sum of all these natural numbers. Okay, but if the value of num is 1 or less than 1, so what we are going to do, we are going to return 1. So this is our base condition, because after this we don't have any number. So if the value of number become 1, we have to return 1, else we'll return num plus sum num minus 1. Okay, so this is how recursive function works. So this is inside the sum function, we are again calling a sum function. So this is recursion, and second condition is there is a base condition. It means that after this there is no execution of program. Okay, so let's run this code. Suppose, so after returning, where it comes to the call function. Okay, so where we have called the function sum n, so let me store this in s, somewhere in s, and let me print the value of s. Printf %d and s. Fine, so let's run the program. Enter n. We have to enter the first, how many natural numbers you want to read. So suppose let me start with 5. Okay, 5 natural numbers. Okay, so here 5 will be passed here. So int sum, here 5 is there. Is num less than equals to 1? No, it is not equal, so it goes to else part. So here it is. So what happens here? Here it comes as 5 plus sum 4. Okay, so it is returned to this function. So here it becomes 5 plus sum 4. Okay, so again this recursive function always works on the principle of a stack. It means that the results are stored like this: 5 plus sum 4. So in next iteration it becomes 5 plus 4 plus sum 3. Like this it goes on adding itself. Okay, so again sum 4 is there. It means that it has not been terminated, it is calling itself now by passing number 4. So it goes here 4 less than equals to no, so it becomes here 4 plus num3. So again it goes there. So now 5 plus 4 is there. It is calling sum3. So again like this, 3 is there. So 4 plus 5 plus 4 plus 3 sum 2. 5 plus 4 plus 3 plus 2 plus sum 1. Finally the value of num become 1. So num is less than or equals to 1. Yes, it is equal. So it will return 1. So finally the value here becomes 5 plus 4 plus 3 plus 2 plus 1. Okay, so this is our answer, which is stored here. Finally it prints the value, and the sum of value is whatever is there. Okay, so like this the recursion works. So let me solve some questions for you so that it becomes easy for you to understand. So next question is question number 2, which is write a program that will evaluate a floating point number to be raised to an integer power using recursion. Okay, so again this is very important question. So it is like y equals to m to the power n. Okay, so here what is this? Y is the output, m is the base, and power is nothing but you can tell it exponent. Yeah, so here the base can be a floating point number, but the exponent has to be integer. Okay, so let's go to the programming part very quickly. I hope you have noted the question. Okay, so let's go to as include. Main function is there. Okay, float y, which is for output, and x, which is for base. Okay, int n, which is for the exponent, that is the power. Okay, so we have to read printf enter base number, scanf %f address of x. Again we have to enter the exponent, scanf %d address of n. Okay, so let us call the function. So here I didn't define the function, so let me declare the function here. So it is of type float. Okay, because we are finding the power of a floating point number, so float. Let me name my function as power, and the data type will be float for the base and integer for the exponent. Okay, so this is my function declaration. Let me call my function. So it is power, will pass the base number and its exponent. Okay, so let me store this here in y. The value, whatever the value of this comes from here comes, we are going to store it in y, and finally we will print the value of y, whatever is there. Okay, so result is %f and y. Fine, that's the end of main function. Let's go to the power function. So float power, float base, and int exponent, it is e. Okay, sorry, there will be no semicolon, so curly bracket started. Now the base condition. Okay, if the value of exponent is less than 0, it means that it is a negative number. So what we'll do, we'll print error. Okay, it cannot be raised to negative number, so we'll print error. Else if exponent is equals to 0, so anything to the power 0 will be equals to 1. So we'll print, no, sorry, will not print, we'll return. Okay, we'll return 1. Else finally if the exponential power is not 0, it is not less than 0, it is not 0, so it must be greater than 0. So we are going to return else return base into power. Sorry, we have written it as b, not base, so let me correct it. B into power b comma e minus 1. Okay, that's all. So how it is going to work? Okay, suppose we are going to find the power of 2 to the power 3, 2 to the power 3. So how we are going to do is we are going to perform it as 2 into 2 power 2, 2 into 2 power 1, finally 2 into 2 power 2, 2 into 2 into 2 power 1, 2 into 2 into 2 into 2 power 0. Okay, so 2, 2, 2, 8, 8 into 2 power 0, which is equals to 1, so it is 1 only. So anything multiplied by 1 is that number only, so the value comes as 8. So this is the method we are going to perform. Okay, so here this is your base condition, this is your base condition, and this is your recursive function. Fine, so this is the way we are going to perform. Recursively we are going to call a function. Fine, so I hope you got this code. This is also important. Let's go to another question, third question. So very slowly I am going to increase the questions, like easy to harder question I am going to perform. So third question, it is very important question, very important question. Write a program to generate the term of, we can say nth term of Fibonacci series. Okay, it is very easy but very important question. So let me write the code for you. So has include, okay, int main int n, okay, and let me take a variable r for result. So printf, enter the term, okay, that you want to find, enter the term, scanf %d address of n. Next is r equals to okay, so again I forgot to declare the function, so let me declare here. So the function is int fibo and int, okay, so this is my function declaration. So r equals to, we are going to call the function fibo and we are going to pass our term. Okay, finally we will print the value, printf let me write like this, %d term is %d, okay, so %d is n, it means that the nth term of the Fibonacci series are whatever is stored here. Okay, so that's the end of my program. Let me go to the recursive function. So let me write the function definition here, int fibo int, we can write the same variable, yeah, so I'm writing n only. So let me write the base condition. If n equals to 1, it means that we are just giving a first term, so it will be 0. If you remember Fibonacci series, it starts with 0, then 1, then 0 plus 1, 1, 1 plus 1, 2, 2 plus 1, 3, 3 plus 2, 5, like this, yeah. So if n equals to 1, first term, it will return 0 only. Else if n equals to 2, we are going to return 1. Okay, so we know this base condition. These two numbers we have to know, okay, for generating a Fibonacci series. So if the term is 1, the value of the term is 0. If the term is 2, the value of the term is 1. Else we'll return Fibo n minus 1 plus Fibo n minus 2. Okay, so if the term is suppose third term, Okay, if the value of n is 0, if the term is 1, sorry, if the value of n is 1, we'll return 0. If the value of n is 2, we'll return 1. If the value of n is 3, it means that we come to else part. So it is Fibo n minus 1, that is 3 minus 1 is 2, plus Fibo n minus 2, which is 1. Okay, so here see the base condition reaches here. So Fibo, if the term is 2, if the value of term is 2, the value is 1, and if the value of term is 1, the value is 0. So 1 plus 0 is 1. It means that the third term is 1, yeah. So 1 is there. Okay, like this recursively it is going to call itself. Fine. Okay, so let me go very fast to some important question again. Okay, so this question has been asked in exam. Yeah, so let me solve for you. Question number, I think it is 4 is there. This question has been asked in exam, so let me write the question for you. Write a program in C to calculate the sum of digit of a given number till a single digit is obtained using recursive function. Okay, if the sum contain 2 or more than 2 digits, then go on adding the digit till you get a single digit. Okay, it means that first of all understand the question. So what it is telling is, for example, if you are giving a number, suppose if your number is 5, 4, 7, 8, find the sum of it. So 5 plus 4, 9, 9 plus 7, 16, and 16 plus 8, 24. Okay, is it a single digit? No. So again add this. 6. Is it a single digit? Yes. So you have to perform this using a recursive function. Okay, fine. I hope you got the question. So let me solve this for you. So it's very easy. What we are going to do in this question, we are going to use two functions. One function is to find the sum, and one function is to check whether the digit is single digit or double digit. Okay, we are going to use two functions. One function to find the sum of digit, and one function to check whether single digit has come or not. If single digit had not come, we will again send it to the sum function. Fine. Okay, so let me solve. I will also execute this program and show you. Okay, so has include, let's start from here only. Let me declare a function, sum function. Okay, and let us take the variable data type as long int, because the number can be greater than integer. So int, one recursive function I will prepare, long int. Okay, int main. So long int n, and another variable let me take as r. Okay, printf enter n, scanf %d address of n. Okay, let me call the function sum by passing the value n. Okay, and let us store whatever the value comes in r, and we'll print sum of digit is %d r. Fine. So let's go to the function part. So I told you we have to take two functions, but first of all let me, as it is calling sum function, so let's go to the sum function. Sum long int n. Okay, int okay, let me take another variable. So s I have used, no I have not used s, so int s. Okay, so here I'll call another function, that is my recursive function, and I'll pass the value n. It will be stored in s. Okay, see, I am passing my number, whatever number is there, to some function. In some function it is going to call this rec function, which is going to add each digit. Okay, so it is going to add each digit and store in s. For example, 4729. Okay, so 4 plus 7 plus 2 plus 9, this sum is going to be performed by rec function. Whatever sum comes, that is 9 plus 2, 11, 18, 19, 20, 22 is there. Yeah, so this 22 comes and get stored here. Now we have to check if s is greater than or equals to 10. It means that it is a double digit number or a single digit number. Okay, if it is a double digit number, it means that it is not a single digit number. We are going to call the function, this function again, by passing the value s. Else we are going to return whatever the value of s is there. So where it is returned? It is returned here. Okay, I'll again explain this. So let's go to the recursive. Int rec long int n. If n is equals to 0, return 0, else return n mod 10 plus sum and divide by 10, and the bracket closes here. Okay, so let me explain this. Let me explain from here. Enter a number. So let me enter a number as 4729. The number is passed here, it comes here, so the number is 4729. Here it comes, it calls the function rec, so the number goes here, that is 4729. If you remember this code is for finding the sum of digit. Yeah, n mod 10 plus sum and divide by 10. Okay, so this is a function for finding the sum of digit. Okay, so n mod 10, it means the value becomes 9, and sum and divide by 10, it means the value become 472. Okay, so it goes here, so the value becomes 472. Again it passes to recursive function, so it comes here. Previously it was 9, so now n mod 10 becomes 2. Okay, so 9 plus 2. Okay, so again plus sum and divide by 10 is 47. It goes there, 47 passed here, again recursive, so again it comes here. So previously it was 9 plus 2, now it becomes 7 plus sum n by 2, which is nothing for 4. 4 comes here, again it calls itself, comes here, and divide by 2, so now it becomes 4. So 9 plus 2 plus 7 plus 4, and divide by 2, the value becomes 0. Okay, so again it comes here, now the value is 0, it is passed here, n equals to 0, yes, so it returns 0. Hence the value is 9 plus 2 plus 7 plus 4, which is nothing plus 22. Okay, so where this value is returned, this 22 value, it is returned to calling function, that is the value of s becomes 22. So it checks here, 22 is greater than 10, yes it is greater. So if it is greater, again it is passed to the sum function. Okay, now instead of 4729, now the value of n becomes 22. So the same process is followed. Again the value of 2 plus 2 is done here, 2 plus 2 is 4. Okay, so the value is returned here as 4. Now again it checks, 4 is greater than or equals to 10, no it's not greater, so it is going to return the value of s, that is return s. The value is returned here and it is displayed as the sum of digit is 4. Okay, so same code I have done here. If you see, same code I have executed here. Please see the code once. Okay, same thing is there. I have main function is there. After that I have written a sum function. Okay, so if you see, it is a recursive function. because here this sum function is calling itself. Okay, this is not a recursive function because the recursion is calling sum, not itself. Okay, so this is not recursive, but the recursive part is here. So in a program you can use a recursive function anywhere. Okay, let me execute this code. Enter n, so 4 7 2 9. Okay, the sum of digit is 4. Fine, so please see this code. This is the main code, this is the sum code, and this is the recursive code. Fine. Okay, so one last question I'll be doing for today. So someone has asked me in comment box. Let me see the question. Yeah, so the question is question number 5. Okay, so the question has been asked in I think 2074. So the question is, write a program in C to find out whether nth term of the Fibonacci series is a prime number or not. Read the value of n from user and display the result in the main function. Use a separate user defined function to generate the nth Fibonacci term and to check whether a number is prime or not. Okay, please read the question before solving it. Okay, because this type of question is only lengthy, there is nothing is question. Okay, so this, what is this question? You have to write. Generally they have told you to write two functions, one Fibo function for finding the nth term and one prime function to check whatever nth term is there, it is prime or not. For example, they have asked you to find the fifth term of Fibonacci series. So what is the fifth term? 0 1 1 2 and 3. I think this is the fifth term, 3 is the fifth term. Okay, so one function, Fibo function, you have to find the term, again pass this term to prime number function to check whether this number is prime or not. So it is a prime number. Fine, you have to use two functions here. So let me solve this question for you. Again, this is very easy. I hope you noted the question. So has include, let me declare two functions, one Fibo function, okay, one is prime function, void, sorry, int main, try to write int main instead of void. Okay, int n for my number, f for my Fibonacci, storing Fibonacci term, and p for storing the prime number. Printf enter n, scanner %d address of n. Let me call Fibo function, passing the value of n. Whatever the value of term come, it is stored here. So now let me call my prime number function by passing the value f. I hope you got it. The value of term we have to find it as prime, so we are going to pass f. Finally, after, okay, so let me first solve because after this we don't know what happens. So let me just end this here. Let me go to Fibo function, we'll pass the value as m. Okay, so if m equals to 1, return 0, you know, previous, remember previous recursive function, yeah, same thing I am writing. Okay, else if m equals to 2, we have to return 1, else return Fibo n minus 1 plus Fibo n minus 2. Sorry, I think it's m, not n. M minus 1, m minus 2. That's all for Fibonacci. Now let's go to prime. Int prime, int x. Okay, so I think you know prime number also. So let me declare a variable I for loop and c for my counter. So for I equals to 1, I less than equals to x I plus plus. So in this case, it should be divisible only 2 times. 1 by, if a number suppose 3 is there, so it should be divisible first by 1 and then by itself. It means that value of c should be only 2, not greater than that. Okay, if x mod I equals to 0, we are going to increase the value of counter as c plus plus. Okay, and finally we are going to return the value of counter. Okay, so bracket close here. Now here, so whatever the value of counter is there, it comes here and stored in P. So if the value of P is 2, it means that it is a prime number. So we will print here the nth term is prime number, else we will print it is not a prime number. Okay, so I have not written this code properly because I have already solved in DevC. Okay, so here is the code. Okay, so here I have called Fibo function and prime function. So in Fibo function I have found the Fibonacci term, and in prime function I have found the the value is prime or not. After that we will return the value of c. So here the value of c is returned here. If p equals to t, the percentage d term of Fibonacci series percentage d, and it is a prime. Else the percentage d term of Fibonacci series percentage d, and it is not a prime. Okay, so n means which term we are find, f means the value of Fibonacci term, it is prime or not, we are going to solve. Okay, just see the code once. So this is my main function code, this is my Fibonacci code, and this is my prime function code. Okay, so let me solve. Enter the term of series. So I want to find the fifth term. So the fifth term of Fibonacci series 3, and it is prime. Okay, fine. I hope you got this code. Okay, so there is one more question here. I hope I can solve this. Okay, so there are I think 2-3 more questions. Okay, so I think I have to make part 2 because that's all for this video. I think it has become so lengthy. So 3-4 questions is there, so I'll be making a part 2 of this. Okay, so stay tuned, and if any query you want to ask me, if any question you want us to solve, please comment so that we can solve that question. And stay safe, and thank you.